Hey everybody, it's Mr. N, and we are going to do some differentiation formulas. Basically, today we're going to learn the shortcut for taking the derivative. This is 3.1 in the 9th edition. So first thing we got to remember is that the derivative of a constant is 0. Now I know this seems kind of basic, but I really have to point this out because you do not know how many times I see students make this mistake, especially when you're dealing with things such as pi. Remember, pi is a constant. And if you have values such as if they say e to the first power or e squared, etc. Not e to the x, if they just say e to the first. These are constants, and the derivative of these would be 0. So it's important to remember that the derivative of a constant is 0, because that's going to come up, and we don't want anyone making that mistake. Now, for power functions, here are the rules. If n is 1, the derivative with respect to x is 1. So, if, for example, I have x to the first power, this derivative would just be 1. If I had x squared, this derivative would be 2 to the x, and x to the third, this derivative would be 3x squared. You see a pattern going on here. Yep, we see the pattern. So hopefully you can see that pattern. And the pattern becomes this power rule. And in this power rule, based on our pattern, what we are doing is we are taking this n and we're putting it out in front and then subtracting a degree. Just like we talked about how when we are graphing derivatives, the order is coming down by 1. So if it's a third order polynomial, it becomes a second order polynomial. So in other words, if this was x to the third, I am taking this 3, bringing it out in front, and then subtracting 1 from the 3 up here. So this becomes, the 3 comes out in front, and then I have the x, and now it's going to be 3 minus 1, so this will be 3x squared. So that is how we work with the power rule. Let's do another example. Suppose I had 4x to the 6th. Again, I would bring this out in front, so I still have the 4. So f prime of x in this case, I still have the 4, and I brought the 6 out in front, and then I have x to the 6 minus 1. So now I have to combine these to get the 24, and this would be x to the 5th. Okay, and I combine these by multiplication. So let's find these other two examples. Over here, f prime of x would be 5x to the 4th. Because again, the 5 comes out in front, I subtract 1 from the 5. Over here, f prime of x, I'll pause for a sec, see if you could do it. Good. This will be 200x to the 199. All right, so let's do another example. Suppose I had f of x equaling pi. F prime of x would equal 0. Again, this is the derivative of a constant equals 0. Now, let's review y again one more time. Suppose I had y equals 2, and I graph this. At y equals 2, I would get a horizontal line, right? Right there, just like that. Now, if I took the derivative at 2, I'm looking for the slope of this y equals 2 value. Well, what's the slope? 0. So that's why, again, the derivative of a constant is 0, because the slope is 0. And now let's just do one final example. What if you had f of x equaling 3x? The derivative would be just 3, because in front of here, this is a 1, and 1 times 3 is 3, and then I take my x to the first power, bring it down a power, so by subtracting 1, and you get x to the 0, which goes away. So this goes hand in hand with our power rules when you have x to the first power that we talked about right up here. Okay, so let's go ahead and move on, which brings us to the constant multiple rule. So if c is a constant, f is differentiable, function, then the derivative with respect to x of c times f of x is just you keep the constant out in front, which is what we did here and what we did with the example right up over here. So let's take the derivative of these two, and again, here's my constant. So this time I'm going to say 5, leave it out in front, and it'll be times 2x to the first power. Now I can multiply these and get 10x. On the second one, I'll give you guys a second to try it. And this becomes negative 8x to the third because it's the 4 times the negative 2, and I bring it down 1 power. So basically our general rule is we're going to take f prime of x right here, and we'll have a constant times n. This will come out right to here, and then I subtract 1 for the power. That is my general rule. Here's another example, 15x squared. This becomes 2 times 15, which gives me the 30, and I bring this down 1 power, which would be x to the first. Now we've got the sum rule. As I like to say, it's sum rule. So over here, that was my dad joke, if f and g are both differentiable, then the derivative of f of x plus g of x, well, you just take the derivative of each of them. We see this all the time with polynomials. So this will tell us that f prime of x is going to be little f prime plus g prime. And we could do it for multiple additions, subtractions, etc. So suppose I had this example. I'll put you one up here real quick. Y equals, we'll say 3x to the fourth minus 5x cubed plus 2x squared plus 6x plus 5. Y prime would be, well, we start off here. We're going to say 4 times 3, which is 12x, bring it down a power. And we're following this. I could take each derivative of these separately. And then over here, I'll get 3 times 5, so minus 15x squared, 2 times 2 plus 4x, because I brought it down 1 power. This becomes 1 times 6 plus 6x. Bring it down 1 power, it goes away, and the derivative of a constant is 0, so that I have nothing else there. So that would be my final answer. Okay, so moving on, let's go ahead and we'll talk about the difference rule, which is the same thing that we just did. I can combine both difference and sum rule, so I can have a negative in here, and I just did that in the example, so you would still take the derivatives. So right here is this whole thing combined, so 6 times x to the fourth gives you the 24x cubed, and then 3 times a 2 minus 6x squared, 5 times a 2, 10x, and again, what's the derivative of a constant? The derivative of a constant right here, d dx of a constant is 0. Now, what did we just learn? We learned a shortcut to taking derivatives, because remember, the limit as h goes to 0 of f of a plus h minus f of a over h, this is the definition of a derivative, right? So this is how we were taking the derivatives, by plugging all that in, especially if we had point A. If we didn't have point A, an actual numeric value, we just left it as A. So, but now we have a shortcut. Instead of doing this long formula every time we want to take the derivative, we learned the shortcut. So as a result, the tangent line question becomes super easy. So find the slope of the tangent for this at x equals 3. Well, that means I need to take the derivative, right? Because I'm looking for the slope of the tangent line. So this becomes y prime equals, now I'm going to take the derivative quickly. This becomes 6x plus 2, the derivative constant 0. Now I want it at 3, so I'm going to go ahead and plug the value of 3 in. So I'll get y prime of 3 becomes 6 times 3 plus 2, which gives me 18 plus 2, which is 20. And that's the slope of the tangent line. Now, if I want to find the equation of the tangent line, well, I have to put in the point 3. So y of 3 becomes, I put this back in, 3 times 3 squared plus 2 times 3 minus 4. This becomes 9 times 3, which is 27, plus 6 minus 4. So this gives me 29. So I have the point 3 comma 29. So it would be y minus 29 equals 20 times x minus 3. That would become my tangent line at 3. This is my slope, though. So let's go ahead and take a look at our next example. Moving this up. Okay, if we have a particle, position is given by this. Find the velocity and the acceleration. All right, so let's take a look. For the velocity, let's do that one first. S prime of t equals v of t. And this would be just taking this derivative of this equation, and this will give me 6t squared minus 8t plus 6. Again, derivative of constant 0. And now a of t will be v prime of t, which is s double prime of t. So I can go through, find a of t, and I'm going to do the same process. So this becomes 12t minus 8. So there is my a of t equation, and this was my v of t equation. So we got v of t right up here. We've got a of t right there. Now, if I want to find for part b, a of 3, I'm just going to plug the 3 in. So this becomes 12 times 3 minus 8. So this is 36 minus 8, which would give me the 24. And if we wanted to put units on this, it would be units per, say, second squared. Okay, looking at this next thing here. The book defines the number e as this, and we've talked about the number e. Okay, so let me graph f of x equals e to the x. Well, when we graph this, just like every other exponential, we are going to get that. Over here, e to the 0 is going to be 1. Now, what ends up also happening is the slope to the tangent here is also, the slope will also be 1. So, this is at x equals 0. Well, this situation brings up the derivative of e. Okay, not sure why that's not moving up with it, but we'll move that up out of the way. Here we go. So the derivative of e to the x is just e to the x. And later we're going to learn something called the chain rule. And here we would have to apply the chain, and I'll talk more about this later. So we will go ahead and save these examples for when I do talk about the chain rule, and you can check out that video, and then I will come back to these examples because they do involve the chain rule. But let's go ahead and write one that doesn't involve necessarily, they all involve the chain rule, but one that we don't have to worry about so much. So suppose I had f of x equals 5e to the x. Well, f prime of x in this case would just be 5e, because the constant stays right there, and then the derivative of e to the x is just e to the x. It just stays like that. So that would be the derivative there. Now, again, we will do these when I discuss the chain rule because they do involve the chain rule a little bit more, and we'll save that for later. We do have some class examples. We will do all of those examples in class. So thanks for watching. Hit that like and subscribe button, and I'll see you guys in the next video.